This is the Amp Hour Podcast, recorded March 11th, 2012. Episode 86, Emolumental, Evaluation, Emporetics.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Chris Gamble's Analog Life.
Hey Chris, is it daylight saving there?
It is.
Or end of?
It's an hour earlier.
Start off.
Or hour later. It's later in the evening.
Don't you guys do it at the start or end of a month? Do you do it? Why do you do it smack bang in the middle of a month?
It changed a couple years ago, 2007, I think. It was the Energy Saving Initiative by George W. Bush.
Ah, right. Okay.
Yeah.
Well, not by him, because he's incapable of actually thinking, but
Yeah.
Let's not go there.
Yeah.
Right, so it's 1 hour later there, is it?
Yeah.
Cool.
So-
I think our daylight saving ends at the end of this month. Ours is always at the start of the end of the month. So,
Yeah.
Yeah.
It always
well,
messes
near
with
to
us.
it, because it's always on. They always do it on a Sunday,
Yeah.
so it doesn't, interrupt work as much as the. Yep.
It is a Sunday here, so just in case you forgot.
well, of
Monday
course,
there.
of course, right,
Tuesday,
yes.
Sunday here, so.
Yep.
Yep.
Monday morning, because I had I had no idea what time the show was supposed to be on this morning. I'm
No.
always confused.
Yeah.
You're always changing things.
No, yeah.
All right, it's all good.
Yeah, so we have a survey that a bunch of people filled out. Let's see, last count, 331 people had filled out our survey from last week, which is
Wow, thank you very
awesome.
much.
That is
Yep.
very helpful. That helps us for advertisers if we ever get any of those. But more so just feedback. I mean, a lot of it was,
Oh, it's great. The
hey,
feedback
Dave,
was
stop
terrific."
talking about America.
Or keep talking about it.
Keep talking about America.
Not
yeah.
everyone is against it.
Yeah,
everyone
right,
gets the joke. Come on, some people have a sense of humor.
But yeah, it was really good. It was really good feedback all around. And there's some trolls in there, of course. But
right.
yeah. But
But otherwise, it's great. So thank you very much.
yeah,
everyone.
it was very, very good feedback. And we'll try and, a lot of great suggestions. We'll try and roll in as much as we can. And we usually the feedback is, hey, we like hearing about electronics. Why don't you try talking about electronics? And we're trying, people. We're really trying here. Like, we're really...
I don't know. Well, I'm going to talk about 3D printing today.
Well, yeah, you are, yeah.
But we'll get onto that, and then people
Yeah.
complain, oh, he's talking about the freaking MakerBot again.
I mean,
But I don't know.
Yeah.
It's just us. I mean, it's not necessarily just about electronics. It's just
Right.
us ranting on, really. That was how the show started, wasn't it?
Right, yeah. I mean, we were
Just
clueless,
anything we happened to be
right?
working on, anything we saw in the
Yeah,
news or
yeah.
whatever. And
But regardless,
people get sidetracked. I
we
mean, you
love
can't expect us
feedback.
to-
Love feedback in any form. Either a survey or an email or anything like that. We love feedback. Email usually we're a little slower to get back to, but this kind of thing is just awesome.
Yeah.
Yeah. So
Can we go through some of the comments? Maybe we'll
Maybe.
leave people's names out.
Of course. Well, they actually don't have names in here. That was the beauty of it.
Oh,
so
right. Oh,
if-
well, of course.
If
yes.
people are out there
Yes,
listening
you are
still,
correct.
and you still want to get your opinions in, it's show 86. If you go to the webpage, if you go to show 80, or sorry, we're on show 86 now. Show 85 has the survey on it. So if you want to go put your anonymous rants and raves, I mean, we sure
You're
as hell
right.
have
It
ours.
is anonymous.
So,
Yep.
but yeah,
Although
yeah.
possibly, if you're a regular contributor, might be able to track you down via your grammatical
Oh yeah.
talk or something like that. We'll put it through a grammar analyzer and we can find out who
Oh
you
yeah,
are.
because we have
Those who secretly hate the show.
yeah.
Bastard. But there's some funny stuff in here. I didn't go through and highlight them, unfortunately. But
Yeah.
there we go. Printing electronics just not going to be feasible. Thank you very much, whoever agrees
We'll get to
with
that
me.
later.
Yes.
We'll get to that later. I think the most intriguing thing is when you so this is all a Google Doc, right? And you can get to the summary of responses. And so out of the responses, 326 males, 5 females. And so what does that tell us, Dave? All
That
of our
we
female
have some-
listeners don't like taking surveys. That's what it tells us.
Right. How many female listeners do
I mean,
we
it's
have?
got to be half at least, right? I mean, 52% of the world. So I assume that, there's 300 some odd female listeners who did not take the survey as their counterparts did. So,
Right.
get to it, ladies.
Oh boy, the app hour is awesome. Yes, it is. Thank you very much. That was their sole comment. I totally agree.
Well, that's just that's nice of them, but that's not the real. The real value is like some constructive feedback.
Where
chip
do
of the week.
people
Everybody
most listen?
What's that?
Where do people most listen?
Let's see.
Have you analysed the stats yet?
Yes, I have that right here.
Sort of thing.
Yeah. It looks like at home while not in the lab. That is the majority response so far.
Okay.
But I was thinking about this from just a data perspective, right? People that take the survey are probably most likely to be the ones who go and actually check the website. If I was personally listening to a podcast on my cell phone, like I have a pod reader on there, I probably wouldn't be like, oh, I have to go take that survey later. So,
or you'd forget.
Yeah, exactly. So there is a data skew likely there. So we have to keep that in mind too. But it seems like, and I can publish these in today's episode notes. The graphs that Google Docs puts up. But looks like a lot of in the lab, at home, but not in the lab, and then in the car. Those are the big three.
Yep.
So
right, excellent. Somebody said it's like listening to Dean Martin and Jerry Lewis.
Oh, who's who though?
I don't know. Oh, I love it.
Are you going to be the smooth one, or am I going to be the? I mean, Dean Martin was pretty smooth, dude. I don't really.
I am not smooth.
I'm not either. It's like listening to Jerry Lewis and Jerry Lewis.
Right. If anything, you're the smooth one. Come on.
Oh well. All right. There's this.
Just young and too polite. You're not edgy enough. Sorry.
Not edgy enough. Yeah, Jerry Lewis. Nothing like Jerry Lewis to be edgy.
Right. But a lot of the comments were people saying they love the guests. That was
that's a big one.
That's a big one. So
guess is one. Chip of the week is another, and we've got a couple great chips for the chip of the week. I think those are both great pieces of feedback. The usual stay out of politics, which is always a good idea, but it's bound to happen.
But some people like it though. So how do you
balance?
Keep everyone happy, right? People don't mind.
Oh, you don't.
Some people don't mind the tangents,
Right.
And we try and make it relevant to electronics, because there is a lot of politics which drives our industry. So unfortunately, if you're talking about the industry, you're automatically almost have to talk about politics because it really is a big part of it, unfortunately, it or not.
Yeah, no, it is. That's true. That's true.
What are some of the bad comments? Have you got any highlighted bad comments, though?
No, there was one at the top. Let's see if I can find it. One that says wear more hats. I don't get that one.
Right. Talk about more stuff in more detail,
maybe.
Perhaps?
Yeah. Wish there was more guests more often. That's something we're working on. So if people have a suggestion for guests, you can leave that on the suggestion page too. We're going to try not to do too many surveys because people just stop doing. There's always a fall off in terms of usefulness, really, because people get kind of tired of answering surveys. But another comment was one that we've had when guests have been on before is that don't interrupt the guests, which is something that we had trouble with because we're on Mumble, right? You and I, we sound natural interrupting each other because that's just how we operate, right?
Yeah, that's right. That's the show.
Exactly. Yeah, but it's tough when you have a guest because you don't have these visual cues. So that's another thing. But we'll try it. We try that, and no video. So, but overall, great comments, great feedback. Thank you so much. And if people really want to add more comments, please feel free to on Show 85's page. So,
I love this one. Is Dave okay? ? Every now and then he seems to pause mid-sentence and struggle to expel the word that's in his head, and the rest of the time he's going hell for leather. Is it probably buffer overflow? I don't know. Yeah, I'm weird. My mind works in mysterious ways. It is always several steps ahead of my mouth or vice versa. Mm-hmm. I'm not actually sure what it is. It does tend to flip-flop a bit.
Right. So, and one response to that is someone else said to get both of us drunk as well. So
right.
I did have a beer before the show, just so everybody knows. Just for that one listener. So
sorry, but I don't drink.
Yeah, sorry.
Tastes like piss. So yeah.
Yeah. All right. Well, let's get on to some non-survey based stuff because there's some fun stuff on the show notes this week.
Well, we've got some news. I've got some news that I'm very disappointed about. Sorry, it's not electronics, but it's huge. science news.
Okay.
So, and everyone into electronics is usually into science and space stuff as well.
Science feeds engineering, right? I mean,
of course.
There would be no scientists without engineers. I mean, Wolowitz is a key part of the team as much as Sheldon doesn't want to talk about it.
Howard Wolowitz, if you don't watch The Big Bang Theory.
Yep.
Who's probably one of my if you've got to push me to have a favourite character on The Big Bang Theory, it might actually be Howard, rather, because everyone says Sheldon, right?
Right.
So he plays the part brilliantly. But Howard is the master's degree engineer from MIT, and he always cops the shit for it because everyone else is PhD, right?
Yep.
And he's and he's the only engineer in the group. So anyway, it's hilarious.
Anyway, so what happened with science?
Anyway, the world's biggest science experiment, the Square Kilometre Array, the SKA, it's a bunch of radio telescopes that they're going to build. And this is bigger than the Large Hadron Collider in terms of cost and complexity and all that sort of
so like
stuff.
economic stimulus to the economy, right?
Yeah, it's huge to the country who wins the contract. And they narrowed it down. I think there were like half a dozen countries that enter. The US was one of them, but they just wrote them off early because you guys are just too overpopulated. I'm sorry.
Yeah.
And that literally is the reason.
Yeah,
and it came down to Australia and South Africa. And South Africa's bid was made up of like 9 different countries or something, spread all across South Africa. It was like Angola and all sorts of really troubled nations were involved. And anyway, so it came down to Australia and South Africa.
So South
Australia
Africa, the
New
area,
Zealand.
not South Africa, the country. Is that what we're saying?
South Africa is a continent.
It's a continent? I thought it was a country. Am my geography just failing me right now?
I think your geography's failing you.
Okay, yeah, well, maybe I'm wrong, but I thought...
sorry, Africa,
Africa, okay, all right. So South Africa is a country, I thought, because that's where, like, Johannesburg is, right? I mean, like...
Oh, right, yes.
Okay.
Right.
Anyway.
But it's the South African continent.
Okay.
That's what it's often referred to, I believe.
Okay.
Anyway, there were literally like 9 or 10 countries involved. They were collaborating together to win the bid because these radio telescopes, there's going to be thousands of them, and they're spread across a massive area. That's the whole idea, is to get this huge baseline. Yeah. Effectively a 1 kilometre wide dish capture area, but spread out with a huge baseline. So you get the resolution. And the Australian one was actually going to have a couple of dishes in New Zealand as well, just to get an extra big baseline.
So it's like an auto-zero circuit, right? To take it back to electronics, right?
Oh, right. Well, if you want. I don't know about long baseline interferometry has anything to do with
But it's a measurement science thing, though, right? You got to take it. You got to take a background, and then you zero that out, and then you say, okay, now we know what zero is.
I'm not sure how it works. Okay. I'm not going to say that's a good analogy or not. Sorry.
That's okay.
But if anyone wants to correct us, I'm sure they will. Anyway, the whole idea is, like, this is supposed to be the world's, like, highest sensitivity radio telescope by orders of magnitude, right? And so it requires a really quiet location with massive area. Hence, Australia, was one of the big areas, and Africa as well, So it's and I looked at both bids, right? I actually looked at their bid documents. This was quite some time ago, and the South African one was pretty darn pathetic, I've got to say. Right, it was amateurish. It was like, I'm thinking, there's no way in the world these people are going to win. Australia's a given, and no. Anyway, to get to the actual news, as it turns out, I think it was just yesterday, they said that Australia, while we haven't lost the bid, the committee that they put together of scientists to analyse it said this South African one is the better choice. Not technically, the Australian one is a much better technical choice. Our lower noise floor buries the South African one, and no pun intended. And, technically Australia's much better, but ours is more expensive. So they're recommending, the committee's recommending they go with the South African bid. Unbelievable. I'm shocked. And
that's like a lot of engineering projects that happen like that too, where you have competing interests with even within a country. Like big companies are like that too. We're competing interests, and it almost always it comes down to the committee. Usually, that's a big part of it, and then the economics of it are at least these days are a really big piece of that. So that's an interesting decision because
Fortunately, it's not the final decision. The committee's isn't final. It's apparently up to another committee, I guess, or another bunch of people to actually make the final decision. So the committee of scientists was only the recommendation, which is what I don't get. If these were the committee of scientists, wouldn't they have recommended technically the best location and not taken cost into account? Whereas the final committee of, business people, I guess, would have, bloody MBA dickheads would have chosen the cost-effective solution.
Right, exactly.
I thoroughly didn't expect the scientists to pick South Africa because it's not...
Well, that's assuming the scientists actually did do the picking. I mean, sometimes that doesn't always happen, right?
Exactly, because there's a lot of... Sorry, once again, you've got to bring politics into this. Apparently, in Europe, it's apparently a flavour of the month to support anything in these... poorer nations, especially the African continent. It's very financially beneficial for the people in Europe who are part of these committees to actually choose South Africa over Australia, because they'll end up getting contracts through something because, I don't know, there's all sorts of, support things in place to support these developing nations. And unfortunately, that may have had a say in it. So... anyway, I'm shocked. Not happy.
That's too bad. That's too bad for Australia.
And from a logistics point of view, trying to organise all these radio telescopes across, a dozen different nations that are politically not very stable is going to be a big task, I think, for them. So, good luck trying to build this thing in Africa. And, yep.
Yeah, definitely.
I don't know. It's going to be tough. Anyway, Australia spent hundreds of millions of dollars on this bid, but we did get some good shit out of it. We actually built radio telescopes to actually prove the principle and stuff like that. So we've got some new whiz-bang advanced radio telescopes now, which is fantastic. So
well, we got to see you go out and sneak onto the compounds and sit in the satellite dishes, Dave.
All the way in Western Australia.
Yeah, exactly. Come on,
in the middle of freaking nowhere. That's where they built these things because they were proving that it could be done.
Yep.
That they could get the low noise floor. And
come on, man, I'm going west. Why shouldn't you go west?
Because it's probably 3 times more expensive for us to get across the continent as it is for you Yanks.
Maybe, yeah.
Because, they're not rock bottom airline prices all going bankrupt.
I will say it is not rock bottom airline prices. So that's my bit of news. How much did you
pay? Yeah, you're going to Maker Faire.
I'm going to Maker Faire this year. So if there's any listeners out there, yeah, exactly. We were
Sorry, it's not electronics again.
Yeah, sort of. I'll be doing electronics out there, I think it will be. But I'm going to be at Maker Faire, so if there's any California listeners who are going to be at the Bay Area Maker Faire, I think Jeff's going to be out there. We're going to try and do a show from out there. So should be a lot of fun.
Excellent.
Yeah, I'm excited. But yeah,
and I'm jealous.
Yeah, and you should try and get out there, man.
I should, but no, it's too far to go just for that.
Yeah. But yeah, not cheap to get out there either. So it's
no.
It's tough these days, the airlines. It's any days or airlines are tough. So,
right.
Yeah.
Oh well, it's good to see that you finally will go to a big. This is your first Maker Faire, right?
Yeah, it's gonna be my first one, and you know what?
And it's the biggest, right? Which is the Bay Area one.
Yeah, Bay Area one should be the biggest. But like I've said before, it's not the event itself will be fun. I think it'll be a lot of fun. Walking around and seeing stuff and interacting with people. But it's all about meeting people. It's all about making connections and not in a devious way either too. Because I used to think like that, people are so skeezy when
Chris used to be devious.
No. I used to have this. I used to have this thing where I would be like, oh, I hate how people know others and it's all nepotism and everything like that. And it's right. It's not about that though. It's about even you could be the best electronics designer in the world, and it doesn't matter if no one knows who you are. If they don't know that you design electronics, then they're not going to be able to hire you for their next job or consult with you on, some project they're working on. So it's all about getting to know people, and that's the human side of engineering is that you have to you have to meet people. You have to go out and not necessarily, you don't have to like make small talk and glad hand people, but you have to go hang out with people. And you know, you have to be on someone's brain when they're like, who do I know that can work on electronics, right? They have to be like, oh, Chris or Dave, you know, like that kind of thing. So
that sucks though, because most engineers aren't very social in that way.
It's true. It's true.
I've got to say the majority just aren't. I'm not very social. I'm not a people person. I don't go out and, you know, meet half as many people as you do. Not even close.
Yeah, but you do it online too. I mean, like online is becoming a surrogate
online
for
is
it,
different now.
right?
Yeah.
I mean, like someone could ship you design files and be like, "Hey, I need a circuit for this," and they could send you that kind of stuff. You don't necessarily have to be like in-person extrovert kind of personality, because that is difficult. I have trouble with that too. Like, I think of a lot of our listeners could associate with that. You know, like electronics designers typically are not extroverts, but that doesn't mean that you can't be successful in meeting people and you can't meet other cool people. You know, like I'm going to be hanging out, like Jeff's going to be out there. I'll hang out with him. And I know a couple of people in San Francisco that I'll be hanging out with. And it's like, we're not going to be like outgoing, garrulous people, but it's like, you know, like it'll be hanging out and, you know, shooting the breeze and talking about electronics. And that's what's cool about it.
Sweet.
Yeah. So I'm excited.
Well, have fun, you bastard.
Hey, buddy, it's one plane ticket away.
Well, I know it's one plane ticket away. It cost me about, I don't know, $1,400.
Yeah, at least.
Not including accommodation and expenses.
Yeah.
That's a lot of coin.
That is a lot of coin. You're right. There's no small.
Yeah, I'm just in the backwater of Australia here.
Yeah.
You know, nothing ever happens here. But there will be another Maker Faire in Melbourne this year, and I said that I will go to that next.
All right.
And hopefully there'll be one in Sydney as well, and of course I'll go to that.
Yeah, that'll be good.
But yeah, it's not really a Bay Area Maker Faire though. What a shame.
That is too bad.
All right, what else have we got?
Let's get into some electronics. I've been poking around.
No.
I've been. What did you say? No. Oh no. I've been poking around online, doing some part searches lately, and I saw a thing that our European listeners might be interested in, and I actually have our statistics here. Let's see. How many people are from Europe? About 41% of our listenership is from Europe, so that's pretty significant.
That's not too far off mine.
Yeah?
Off my blog one. Yeah, I think, I think Americans make up about 35% or something, and then Europe is probably bigger than that. So, yeah, at 40-odd%.
Wow.
Not surprising. I'm big in Germany, apparently.
Yeah. All right. I mean, yeah, and that's just kind of like where the base of hobbyists are and listeners and engineers.
There's a lot of hobbyists in Europe, a lot of action there.
Awesome. But so for all the Europeans out there, Future Electronics, which, you know, like, and it's like distributors are different site to site, but I was looking around and I saw an article, I think it was on like Electronic Design or, you know, one of those generic sites. And they talked about a new program out there called myboardclub.com. So my-boardclub.com. And of course, this is if you speak English, right? I mean, like, I don't know how many of our listeners out there are speaking or don't speak English, right? Because you're listening to it, obviously. But
yes.
But this is like a free dev board site. So basically, you're trading your information for a dev board.
You're being sucked into the funnel for a free dev board.
Yeah, right. And that'll happen a lot of different places. But,
it's hard to avoid.
It is sometimes, especially when you're getting free stuff. You know, like they're always that's what they're really trading you. They're trading.
Some of these dev boards are expensive. You know, they're worth hundreds of dollars.
Oh yeah,
some of them. So you know, you've got to give a little to get stuff like that sometimes.
And really, there could be a legitimate use for it too. I mean, like you really could need a salesperson to eventually call you and be like, "So, do you need parts?" And you might be like, "Yeah, I need parts." You know, like like there are legitimate uses for it. So don't discount that either. But that was one thing I never really realized. You know, I've always searched on like DigiKey. They all have dev boards on there, and all the distributor sites they have it, and they list the list price for it. And like you said, it's a couple $100, and you look at it, you're like, "Oh, really?" And I paid for it for projects before, but really most of the time
I have, but it's pretty rare, right? It's not really an impulse buy at that sort of price. When it's like $30 or something, they're impulse buy boards, but
right.
Some of the more advanced ones. Oh, yeah.
Well, the thing that I was surprised though is that when I started getting into like some serious design stuff, is that vendors just start throwing these things at you. You know, they list it at $600, but it's not actually $600. It's
they'll actually give it to you for free if you
exactly
ask, sometimes.
Yeah, it costs them $30, and they want to sell you 10,000 parts, so they're going to give you a $30 dev board like it's nothing, right? Just like they'll might buy you lunch and talk to you about a certain part like it's nothing.
Yeah, that's right.
So. I don't know. Actually,
anyway, what happens? So, what you join this club, and what different is it? Just Future? It's just Future, but they're distributors for a whole bunch of manufacturers, right? So,
yeah, and if you have to, and you have to look at how distributors work, really, too. I mean, distributors talk to a lot of different vendors. They all have contracts with vendors, and then they get basically kind of like a referral fee for selling a part or whatever. So they want to try and refer as many people as they can for, like say a Xilinx part or an Actel part, something like that. They want to try and refer as many people as they can, and then at the end of the quarter, the vendor itself looks at how many people are referred by Future or DigiKey or Arrow, whoever it is, and they say, okay, you get X amount of money. So that's how that works, if people don't understand. And I've written an article about this before, because I had no clue how this stuff worked before I started actually getting into the business and stuff. And it's confusing. There's a lot of different people you might talk to, and a lot of people, you have to kind of know who to push on in order to actually get parts, and who to push on to get a free lunch, and you know how it goes.
Yeah. I'm actually quite liking this site. I might join. They've got like all the manufacturers you can list by franchise. They've got Avago Technologies, Cypress, XR, Fairchild, Freescale, International Rectifier, Microchip, Micrel, and NXP, onsemi, a whole bunch of Exmos, whole bunch of manufacturers.
But you're not in Europe, so you might have trouble. You might need a.
Oh, this is right. So it is Europe only. Oh,
yeah, that's what
is it?
I think so, because I think it said somewhere on here it said about Europe. So, but I'm sure there's some kind of similar one in Australia, and really anywhere in the world you are, there's probably something
there won't
similar.
Be a similar one to Australia. Australia's not big enough market, not even close.
No, man. I was talking to someone who said they were shipping all their stuff to Australia these days. Who was it?
But it's still insignificant compared to
I guess in terms
US
of
and European markets and
design.
the Asian markets.
Yeah.
Yeah. That's the problem we have here. It's just sometimes it's just very difficult to get stuff, very difficult to get support compared to other countries, because we just don't have the volume here, and most manufacturers know it.
Yeah. Oh, yeah. Money talks, and I never really realized that either. I started out at a company that had decent volume, and then I kind of went to somewhere that didn't have decent volume, and I'm kind of like shouting and waving my arms and saying, "Hey, over here! I want to buy your parts." And it was just, you don't realize, but they just don't pay attention, because there's no money, there's no guaranteed money in it, and that's what vendors are really chasing. They're chasing guaranteed money. So if you're not showing that, then yeah, good luck with that.
Try working for a military company where your volume is 5.
Yeah.
I need 5 chips.
Yeah.
And that's my entire production volume.
Yeah.
And it's tough. It is really tough.
Right.
So,
I've never really I mean, like, I eventually got out of my funk, and I convinced the vendor that I was actually having some volume. And that's a lot of hobbyists have that problem too, because they'll approach a vendor and say, "I want samples," and they'll say, "What's your volumes?" And you're like, 1.
Yeah, but a hobbyist can end up making 10,000 runs of 10,000s of a kit or something
true.
like that.
It's
a different world these days. Back before you were,
say it.
When I was a boy.
Yeah, there it is.
There we go. It's because we didn't have the information revolution, didn't have the online e-commerce and everything else. Anyone can now make their own kit business and sell tens of thousands of kits. Any hobbyist from their garage. Trivial, easy.
Easy might be a bit of a stretch, but possible.
No, it's if you get a popular one, you can do it.
2-part kit.
Right. But so these manufacturers and these distributors have to learn that the hobbyist can be almost as valuable as the big players there. So
yeah, and it does feed in. I mean, like, and that's
careful.
the thing. Like, these days, like, even open source hardware, right? I'm sure open source hardware manufacturer. You've done those kits too, right? I'm working on a kit myself. Not a kit. I'm working on a design right now. But like, that's a game changer right there, right? It's if you have someone who creates effectively a reference design, it's an open source hardware design. But if 100 people copy it, it's effectively a reference design, and then that could get designed into, thousands of products.
Exactly, without even knowing,
Exactly. So
I know.
They probably do have to keep their eyes open now more than before. I could agree with that.
Yep,
So.
totally. And have a more open mind, and no pun intended.
Right.
With open source stuff.
And I mean,
because it can become big.
And the cost really isn't there. The biggest cost there is that a vendor has to spend time with you, right? Emailing back and forth how many parts you need, what footprint do you need, yada, yada, yada. That's really the expensive part. The chips themselves, like $5 in chips is
trivial.
not a big deal, right?
No, it's nothing.
Yeah, so that's...
In fact, a lot of that is their mistake because if they know you're a hobbyist, they're going to waste their time asking for volume. They can just look, this guy might produce some whiz-bang open source product. I'll send in the chip, but I won't bother getting all the crap details I do for a regular business. I won't waste my time, like the volume and all that sort of stuff. And they want to come and meet you, and they want to have lunch with you.
Right?
And they want to,
exactly.
that's
the traditional
stupid
model
on their part.
Yeah,
right.
Yeah.
And they want to know what product you're working on. They want to know all about it, and they want to help you design in other chips which they have from other vendors. And it's like, no. Most of the time it's no, go away. I'm a professional design engineer. I don't need you to suggest parts. I'm very capable of doing that myself. Thanks. But
yeah.
Some designers like to be handheld like that though. So I don't know.
I don't mind. I don't mind a lunch now and then. I have to say that.
Right. I don't mind that, but
actually, I had an interesting point about that. So one of my best friends is actually he's a buyer. He purchases parts for a large distributor or for a large company, and I think I've talked about him on here before. But he actually chastised me, and I'm like, oh my god, what's the matter here, right? And he said, you stupid engineers, you go out to lunch with these vendors, and then you design in parts that are single source, and I'm screwed. And it's a really realistic complaint from him. Like if you...
Oh yeah, absolutely.
Now, aside from the fact that a lot of chip vendors are moving to that mode anyways, right? I mean, TI and LT could have effectively the same part, but they might have radically different footprints, right? So it's not actually a drop-in. But aside from that, is there actually a valid point there? I mean, should I not be... I don't think I'm actually designing in a part because I get taken out to lunch, but I do... listen to sales pitches because I'm out at lunch. I mean, is that something I shouldn't be doing? I'm not sure. I don't know. He was yelling at me though, so
right.
He was mad.
Speaking of yelling, I have a bit of a flip side story to the small volume thing. I was working at a company, and this was going to be not relatively huge volume, but huge worth, millions of dollars worth of chips. Because these chips are over $100 each. We were trying to design into this product, and we were trying to choose between these two different competing parts. And we had two different reps for these different companies, and they were competing for our business for this part. We were going to use tens of thousands of them, but they were $100 each.
$100 each. Good God.
Yeah. Oh, yeah, these are bleeding-edge analog-to-digital converters. Absolute
okay. Yeah.
bleeding-edge, super low power. There's there were only two on the market that could do the job. Very niche industry in the seismic business. And we had the, we actually did extensive documentation and comparisons and tests and all sorts of things internally to determine what the best chip was. And then we finally decided on a chip, and then because we've spent a lot of time with the dealers trying to get prices and data, because these chips are beta as well. They're often not actual
spec.
Production silicon there. Yeah. So they're, designed for this niche market, just for designed for 5 customers in the world, and we're one of them. So, yeah, very niche stuff. And we finally told him, look, we've decided on the other guy's chip, and man, he just went feral. Absolutely feral.
Feral, like you started scratching at your eyes or what?
Oh. And he was livid that he lost the deal, and oh man, swear words, and came over and and abused the hell out of everyone. And we had the best solution. And,
I bought you lunch and the bagels.
Yeah, exactly. I invested all this time in, and he actually said that. I've invested all this time and effort into you guys, and I got you the best price possible. And well, I'm sorry, but you didn't have technically the best chip. We went with
Yeah, and that's the problem. That's the problem with making friends with salespeople and everything too, right?
That's it. Yeah, because you'll have to turn them down at some point.
That
probably.
Horrible phrase, that phrase that haunts my dreams. It's not business, or it's not personal. It's business, right? Oh, it's business. I hate that phrase so much because it's always personal. Come on, I mean, in that case, it's not right because it's
not. We chose the best solution.
It's not personal. It's technical.
It's technical. Yeah, that's right. Hey, that's a great T-shirt slogan.
Yeah,
it's not personal. It's technical. I'm going to write that down.
All right. I get commissions. You heard it here, folks.
Right.
That's not going to get edited out. Chris gets half commissions.
5% commission on the T-shirt.
It's not personal, Dave. You just got to give me commissions.
It's not personal. It's technical. Okay. Yeah. I think I'm going to get one of those.
All right. That's another thing people mentioned in the survey was that they wanted merch. We'll see if Amp Hour merch ever pops out, but I was looking at stickers for Maker Faire. We'll see if that happens.
Right. We don't make a lot of money on merch. Like on T-shirts, people. I like it when people buy my T-shirts and they try. They do it to support me. But I don't make much on that.
There's no money.
$2 a shirt or something.
Right. Unless you're doing it in volume.
Unless you're doing massive volume.
Same thing as chips, right?
Right. Exactly.
Yeah.
That's right.
Yeah.
Oh boy. It's.
Yeah. Speaking about low volume chips, did you see this article from IBM? So
no.
IBM created an off-the-shelf terabit optical chip. This is from Wired.com.
Right.
Off-the-shelf optics chip that can do a terabit per second. And it does it with 5 watts. And it's like, they wrote it a little weird, right? They wrote 1 trillion bits per second, which sounds a little more impressive. But this is like a $5 terabit transceiver, basically, which is pretty good,
but it's
right?
just a transceiver, right? It's not doesn't have any processing in there. It's just a
no. It's just a transceiver. It's an array of transmitters and
5 watts for a transceiver. Or is that I don't have an order of magnitude on that. Is that how much is that compared to your current solutions out there?
Well, let's see. There's
your current solutions 7 watts, 10 watts.
Yeah, they have. They all have. A lot of them have gigabit transceivers. They all have these
gigabit transceivers on
right. I think they're up to 26 gigabit on the newest FPGAs and stuff like that.
Well, we'll talk about that. Altera have new optical FPGAs.
Oh yeah,
which I might mention. It's not on the list, but I saw it. I don't think it's on the list unless you added it.
No, I didn't add it. I did see it though. Yeah,
well, let's finish this before we get onto that.
Yeah, this is basically it, though. Basically, though, it was an off-the-shelf thing. It wasn't like they weren't spinning any custom silicon. They were just putting an array together. But the fact that they're lower power and everything else, it's a good sign. It's a networking side of things, right? So,
it's huge. There's a huge market for that.
Yeah, and personally, they're talking in the article about huge data transfers, everything like that. I'd be happy to get a megabit at my house.
Right, yeah, I know. This is all backbone stuff. This is all, designed to go into the big data centers and things like that.
Yeah, and there is a big disparity. Important. And I was talking to a vendor again about this with some of the products I'm working on. Even with all this stuff, and you run into this with oscilloscopes and everything else too. Yeah, there's people working on 100 megabit. 100 gigabit. There's people working on terabit stuff. But not me. I'm at 50 megahertz. I'm solid. I don't need to go any faster.
Solid 1980s 50 megahertz.
Bleeding edge 1980s kind of stuff. Really. But I think that's the reality for a lot of people is that I have a oscilloscope vendor come in and say, oh, you can do 10 gigahertz. And it's like, well, I guess I could see a lot of harmonics, but I don't really care past a certain point, right? I need to see maybe to 200, 500 megahertz to see the signals I'm looking at. And it's just, you start to see these market segments, it's so segmented between the bleeding edge and where the average is, I think, that it becomes unrealistic, really. Like it's cool.
I know.
It's cool to read about in Wired and
it's very cool, but it's what a few people will work on that sort of stuff. Few engineers will end up
right, and the design constraints become so ridiculous, right?
Oh
yeah.
That's why Altera now have optical. I'm not sure if you can buy them. Maybe if you're a special customer, you can get beta or something. But they've now announced fiber optic transceivers directly on the chip itself, as in you plug. If you actually, we'll have to put up a photo of the chip. Actually, most likely, because it's cool. It's actually got the fiber optic, like the ST connector or whatever it is, directly mounted on the FPGA substrate. So you actually plug your fiber directly into the top of the chip. So it doesn't have to go through your board. It just goes directly into the FPGA fabric.
Right. And I think that means that they did a bond wire from actual optics to electronic, electron.
I think it must. I think it's not any more complex than that. I think that's what it is.
Well, basically, I think we talked about it at one point where Intel was actually working about a silicon-based optical to, it was basically a built-in LED.
Where actual photons travel through the chip. Right. But I don't think that's the case here. I think it's...
Yeah, you're right. That was
a standard
between
receiver,
the chips.
but it's straight on the chip. So you eliminate any problems due to where you have to mount your transceiver on your board, go through your substrate, go through your PCB material, and then up the BGA balls into your transceiver and all that. When you're talking 10, 20 gig, that is a big deal.
Right, especially for small manufacturers, right? If you can just plug it in, then you're solid, right? I mean,
I've done stuff up to 4 gigabits per second, I think, 4 or 5 gigabits per second on standard FR4 fiberglass board, and and I've measured the bit error rates on that sort of stuff, and it is, it's fairly critical.
Yeah.
To get that sort of right, and that's only at 5 gig, let alone the thing 2030 that they're working at these days.
At high enough frequencies, everything looks like a short, right?
I know. It's just ridiculous.
Yeah.
So that's how they've avoided it. They've got you plug your optical directly onto the chip. It'd be a bastard if you put too much force on it, you broke it off, and you killed your $5,000 FPGA. Oops.
Right.
Rather than your $10 optical connector.
Right. And
I don't think you can just solder that back on.
No. Yeah, you shake it around, you hit it with a wrench, right?
You can just picture you like you're working in the lab, and then you suddenly hear that crack sound, and your eyes dart around to see if anyone saw you doing it. What do you do at that point? And you've just ruined your... because these
turning
chips
resignation, right?
Yeah, exactly. Oh, boy.
I mean, this is really a continuation of what we've already seen in the market. I mean, module design is a big deal.
Oh, yeah.
I mean, I've been looking at power supplies, DC to DC converters. They're pulling everything in because it's getting so much easier to say, okay, we've got 10 discrete pieces of silicon that we can do all these different functions. We can bond wire them into a small package, fill them up with this. I don't even know what that stuff's called. What is it called when you actually make the stuff you make chips out of, like the black?
It's a pod-in. Well, generally modules will be done with a pod-in compound, which is I forget the actual polymers involved and things like that.
Some kind of epoxy type,
it's an epoxy type thing,
Yeah, so basically you throw everything down on a tiny little substrate, you hook all the bond wires together, you put this goop over it, you cure it, and then you say, okay, hey, we have this whole new product, and then they can sell in all these different markets for different costs. You can sell the exact same guts to a medical company for $1,000 as you could sell to a seismic company like Dave used to work at for $500, right? I mean, just because it's slightly different and it's so specialized. So expect to see a lot more of that, and getting harder and harder to get standalone ADCs or DACs or even microcontrollers without all this other stuff in there. So
and the good thing about that is that you can cut a month off your development cycle time because you don't have to dick around trying to get that aspect of your design working.
Yeah, that's totally true.
Because a lot of these things are actually quite, there's a lot of trial and error, very critical, a lot of calculations involved, and it's easy to goof it up. Whereas if you buy a module that's already pre-engineered, then...
I mean, I've always said that's where all the really tough engineering work is going. If you're an electronics designer and you really want to work on specific solutions and lots of different error cases and stuff like that, unfortunately, you have to go work for a chip manufacturer because, if you're working, again, let's go to medical, right? And you're looking at it like a ECG or an EKG, and you want to look at human body monitoring. you're not going to really do that in a company anymore where you're actually doing op amps and in amps. Some people are doing that, but because of space constraints and power constraints, that's all happening at the chip vendor level now, where LT's doing that, TI's doing that, and they just give you a module. They sell that to an integrator, and they say, yeah, just go tie that to your micro. So all I look at that because the analog engineers, that's where all the fun analog stuff is these days, really. So... yeah.
And the industry has to go in this direction because not everyone can engineer everything from scratch. Otherwise, we wouldn't get any products out the door because your funding would run out by the time you actually developed all this stuff if you had to do everything from scratch.
Right. It's totally a response to the market. You're totally right about that. And it stinks from I remember viewing this from a student's perspective and being like, oh, I don't actually get to design anything. And my response to that student of many years ago would be, you're not going to have time to worry about it. I mean, you just got to get this stuff out the door. Just go. Like, what are you doing? Why are you standing around? Just go. That's the response. Sorry, Chris. No thinking about printed transistors or how your op amps are working. No, you just got to get that stuff out.
Speaking of which, you put a thing on here about a 10K transistor printer. It's not a transistor printer. It prints freaking just conductive traces.
Oh man, this is great.
Break.
This is great. It can do all right. So everybody knows our regular argument on here, and yes, it was on the survey. Stop talking about printable transistors. I don't care. I'm talking about it anyways. This one's good because what happened was, so I write on a site called engineerblogs.org, right? People might know that. One of my co-writers over there, she works at the University of North Dakota, and she had agreed with me the whole time. I never knew why. It turns out one of her coworkers is working on this exact thing, and she couldn't tell me about it. Finally, this stuff went public, and she was yelling at Dave on Twitter the other day. So great article. 5-micron transistor resolution.
But they're not transistors.
No, they are. That's the thing.
Nowhere in there does it say it's actually printed a transistor.
Okay, nothing in here says that, but Cherish said that specifically, that they do have semiconductors and they are printing transistors. So ha 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 ha.
Well, no, I'm sorry. Put it in the damn article.
All right, I mean, this is like
all I've got to go by is the article. Okay?
Yeah, but this is like a Fox News or Fox 6 kind of. This is like a local news channel site. I mean. You're not going to see
find me better info,
all right,
damn it.
I will. I'm going to. And ha ha ha. But anyways, it's pretty cool what it is so far. This one's actually specific to like a substrate, and then you print like RF transceivers and that kind of thing. But pretty cool. And the printer itself costs $10K, which is not cheap, but definitely garage-esque, wouldn't you say, Dave?
I would, yes.
All right.
It's not out of the reach of the well-heeled hobbyist or midnight engineer.
What do they call that?
I would agree.
It wasn't an amateur. It was like prosumer. Have you ever heard that term before?
Prosumer, yes. My camera is classified as a prosumer camera.
That's what I've heard that referred to as. That's interesting. I've never heard that. I heard that term for the first time the other day.
Yep. Professional consumer. Yep.
Mostly consumer with a lot of money to blow.
Yeah, exactly. That's pretty much it.
Yeah.
But in my case, my camera, it's got some pro features in it, like, proper VU level meters, and things like that, and audio mixing that you wouldn't get in a regular consumer level.
Right.
Hence, it does have a lot of, meaning, this prosumer thing.
Yeah.
Because you get these professional features.
Yep.
It's great.
Speaking of the small manufacturing like chips, there was a Hackaday article about. I'm not sure where this actually came from, but it was like a micro manufacturing. And this is actually a mechanical side of things, and it's super creepy. It's actually like you print these very small structures, and then the way it's actually manufactured is it can pop up into a mechanical feature that actually is like it's like a lattice that could actually support some larger amount of weight than it looks like it could. But it's the same kind of thing with like small manufacturing that can do a lot of cool stuff. So since we were talking about small stuff, I thought I'd pop that in there too.
It could be the future of business cards.
Yeah, and that'd be
what?
Well, I mean, it's about the size of a business card. It's not actually. I mean, it could be a business card, but really, it's about the size of a business card when it's printed, and then it's like a 3D printed structure basically, and then it can pop into you can pull it out, and it turns into something else. In this case, a dragonfly, which is totally creepy.
Right. Speaking of 3D printed things.
Yes.
I got my MakerBot working. Sorry.
No,
We've got
that's
to talk
fine.
about because people have asked.
I've been asking,
always
yeah.
constantly ask, follow up. Have I got my 3D printer working? And yes, I got it working, and I've just finished editing a video, and I will render it as soon as this show is finished and upload it.
Nice.
It's about a 30-minute, 25-minute video of us trying to get the bloody thing working.
Yeah,
Took
I was
us like
watching
half a
yesterday.
day to get this thing going.
Yeah, I was watching
by
on
the way.
Ustream yesterday.
Yeah. Oh, okay. You were.
I was just
one
poking
of
in.
the,
Yeah.
right. One of the perverts who were watching without.
Yeah.
Yep.
Heavy breather, mouth breather, right?
Yeah, right.
Extrude that
boy.
plastic.
Yes. And we finally got it working. And I'm glad because I'm always preaching that I hope your project doesn't work. You know, because when it doesn't work, you have to troubleshoot it and you'll learn stuff. And we learnt so much when our MakerBot didn't work the first go. If we just built it via the instruction, we turned it on and we press print, it's a bit disappointing that it doesn't work. But then you start to troubleshoot it and you learn why it doesn't work. And that's really quite valuable.
Oh, yeah.
And we learnt that it's very critical. The belt tensionings are very critical in this thing, and how the MakerBot design seems to be not have much margin for error. You know, it doesn't have big tolerance bounds and things like that. So the not only the belts have to be just right; they can't be too loose. Or too tight, because if they're too tight, then there won't be. I'm presuming don't know this for sure, but it seems like that the stepper motor won't have the torque required, and it may occasionally skip a little step occasionally. So we found that our design was like offset because it would skip a step. So each layer, when it tried to print each layer, and you can see photos of this and you can see it in the video, it will actually, each layer will be slowly offset by a bit because it's mysteriously skipped a little step here or there. And it doesn't know that because the MakerBot doesn't have any ability to determine the absolute position of the motor, right? It just knows here's the reference position, and I've put in 100 steps into the motor, and I'm just assuming
Oh,
the
so it's all
software
open loop,
assumes
huh?
it's just assumed that it's moved 100 steps. It doesn't know it's moved 100 steps.
Well, time to work in a closed loop solution, Dave. A little PID controller
possibly.
and a distance monitor or something, I guess.
A distance monitor, a laser distance monitor or something like that, which
there you
measures
go.
the distance.
I
Because
think we just created Dave's next hack. There we go.
And by sheer happenstance, Murphy's Law, of course.
Of course.
The first thing we tried to print was a little Space Invader symbol, and it's actually quite complex, and the motor has to, and the thing has to move around quite violently in the X and Y directions, right? So it's got to make all these quick, sudden movement changes, which actually backlashed into the belts and then backlashed into the motor and made it all out of whack in one axis. And you can see this in the video, and I tweeted some photos
Yeah,
too.
I'm looking at the photos right now.
And then we couldn't figure out why that thing was printing crap. And then we decided to print a nice little cylinder, which is a perfect test to see if your XY stability is all good, right? If your cylinder's perfectly round and the layers aren't offset. And it actually prints that very slowly and carefully, so at a slower pace. So there's not all this violent movement, which can backlash into the motors and the belts and
it's
muck things up.
a good
So,
exercise in troubleshooting. It seems like. I mean,
so
try some known motions, right? I mean, you knew with the
slow known motions, and
Right.
that was the key apparently. So there you go.
All right,
Rather
cool.
interesting.
Yeah.
So it was almost working all along. We did have a few belt tightening issues, but it was also the default speed it was running at, and the fact that we had this complex object that made it violently shake and throw things out of whack. Because we're talking movements in the order of 100 microns or something like that. Like really tiny stepper motor movements, and it doesn't take much to actually skip one. So. Yeah, trap for young players, but really interesting stuff. How critical
Dave's becoming a mechanical engineer. Look at that.
These motors are. I am.
That's fun. I mean, and that's kind of the next extension of like the blinky light, right? I mean, it's going from changing your environment from changing a bit on a screen to changing the photons output from an LED in order to and now it's actually making making things move. And, there's...
Well, I find that a fascinating aspect of the electronics engineering industry. When you've got to do physical stuff, you have to get into the mechanical engineering side. I've done a hell of a lot of mechanical engineering for an electronics engineer. I don't know about you, but I've done an awful lot of it. And I've got down to the level of physics
mostly,
of how,
mine's
how things
stuff.
vibrate and stuff like that, you know, really physics level stuff. And maybe that's just the industries I've been in. Well, I'm sure it's the industries I've been involved in, but, you know, not everyone will come across that. But, gee, you know, just automated test jigs and things like that for electronics. I've got a new board that I want to test. I've got to, you know, I'm the only engineer in the group who can do this sort of stuff. So I'm tasked with doing some automated production test jig. Well, I've got to, you know about all the mechanics of it and how the test probes work and pneumatics and things like that. And
well, if you're the only engineer in the group, you're doing everything. You're the civil engineer, you're the environmental engineer, you're the coffee engineer, you're the bathroom engineer, you're the trash engineer.
I'm the safety engineer.
Exactly. You don't get a choice there, but that's actually good advice for our young listeners. Which let's see, how many of our we have student listeners?
Oh, we've got age.
59.
Did we put age on there?
We did. I didn't get the finals because it was all by numbers, so I didn't actually do that. But so 15% of our listeners are students, apparently, assuming our sample size is big enough. But that's a good thing. You know, like I've always said that to people: if you're going to do an internship or co-op, go to a small company, because you won't just sit in a cube and be tasked with one thing. You'll be thrown in, and they'll be like, just go figure it out, man. Just get in there and just go figure it out. We don't have time for this, right? So,
and you'll do all this cross-discipline stuff, which is so valuable.
Oh, and that's why I said I wanted to be an engineer. I didn't want to sit at a desk and do the same thing every day. I wanted to just do different stuff every day. I didn't want to sit there. I wanted to try different things, and that's what's important.
But the flip side is sometimes it can be a pain in the ass because you're responsible for everything.
Of course
when
it is.
The whole thing doesn't work in the end,
right?
There's only one
totally
person
your fault.
that gets the finger pointed at them.
Oh yeah.
So with great power comes great responsibility.
Yes, thanks, Uncle Ben.
Oh boy.
So speaking of trial and error, I've been fighting KiCad. Oh boy, you're in for a treat if you ever pick your videos back up again.
You say KiCad. You're a KiCad person. I say KiCad.
Yeah, K-I.
Yeah,
Kai.
I'm not sure which one's technically correct.
Yeah, it
You'd have
matter.
to ask the original authors. I don't think it matters.
No, it doesn't at all. I mean, they're French, right? So it'd be like,
okay,
Le KiCad.
Le KiCad. It's in French. Yeah.
But yeah, I mean, just, it's just the troubles of learning a CAD program. I know we've been talking about it for the past couple of months, or episodes rather, but man, just like figuring out where buttons are, that alone is enough to like just make you want to tear your hair out.
I know. I did 3 videos of that.
I know.
Which some people didn't like.
They were okay. It's tough because
they were exactly as advertised.
Well, yeah, exactly.
That's the thing. I made it clear up front that I was going to do a video without having looked at any of the tutorials, without having tried the program before, and I'm not going to edit the video. I'm just 1 hour of me dicking around.
Right. And the tough part about that is like, even if there are tutorials, they're not that great. I mean, there are some good ones, but they're not like all inclusive, right? And KiCad is getting bigger. Like I heard on Zombie Tech the other day, they interviewed James Neal, who is Lane, the PCB service, right, from Dorkbot, who I'm going to use. I mentioned that I was going to use.
Oh, okay,
right. That purple boards, but and he was talking about how he's seen an uptick in KiCad, but you haven't really seen the. I think that's still kind of not first adopters, but adventurous adopters of trying to try it out without necessarily tons of tutorials. So the tutorials will come much later, I think, and that's so. Even if you wanted to, I don't think you'd be able to. Really, you'd have to just go figure it out and struggle, just like the mechanical stuff that you were talking about earlier, right?
Yeah,
you just gotta figure it out sometimes. Click around and figure it out. So
use common sense too.
Yeah, and even the other day, I did something I hadn't done ever. I pressed F1, Dave.
Oh, you didn't.
I did.
Fail.
I was hopeless. I mean, I didn't know what else to do.
And did F1 work? Did it
No,
provide
it did.
the
I think
solution?
it popped up as pages that didn't exist or something. You know, like,
Nice.
I know. Such a relic. Such a relic of the old days.
Yep, I agree. Oh, God.
Yeah.
Do people use help anymore? I've got to admit, I rarely have tried
Google
to press F1. You know, like, I just don't expect it to work anymore. It's gotten, you know, I
expected it to take me to their Wikipedia page, you know, or whatever their wiki is.
I expect things to be so... maybe I'm naive, I don't know, but I expect things to be fairly easy to use, fairly intuitive, fairly simple. And I don't think it's a huge ask, really. But I guess everyone's idea of intuitive is different. So unfortunately, if you get someone writing a CAD program whose idea of intuitive is different to everyone else in the industry, or a majority in the industry, like, you know, like if you don't expect to be able to edit a part by double clicking it, if they don't think that the person who wrote it doesn't think that's an intuitive way to do it, then, well, you know,
or the ultimate
the 90%
paradox
who think it is,
we mentioned last week, right?
You know?
I mean, in order to make a Spice program, you have to be a programmer, even though hardware people are going to use it. You know, it's the same thing with CAD programs, right? I mean, some software people use CAD programs, but it's mostly software people writing it.
It's engineers. That's right, and they expect it to work in a certain intuitive manner.
Yeah,
I guess
that's tough.
Based on it's also based on history of other like programs as well.
Right.
So
you
know, I guess if you wrote the first ever spreadsheet, you know, if you're Dan Bricklin, I think, is my history correct? Someone will correct me on that, but I think it's Dan Bricklin. You know, wrote the first spreadsheet. Like, nobody had ever seen anything like that before, so they had no idea how it was supposed to operate. So you dictate the rules, you know, from day one. So you sort of set down the standard, how people expect something to work.
Right.
But, CAD programs have been around for 30 years, you know, plus, more.
Yep.
So, you know, people expect them to work in a certain way, I guess.
I was thinking about that the other day about CAD and how it must have been so different. You know, they used to call it tape out, right? So they used to.
Oh yeah. So, you used to have tape. I used to do that.
Really, I've never seen that.
I used to do tape on clear film. You would do, you know,
awesome.
and you'd have the light box with the tape, and you know, I actually used to do all of my. I actually used to do my tape outs backwards. I would do it in my head backwards, and I would lay them out. All my pin outs, I'd actually put them backwards so that the tape was actually directly against the surface of the board, so that I didn't have to do a negative first. So I'd skip an entire step.
Nice.
I'd skip an entire production step, but it actually required you to think backwards and do your layout as a mirror image.
Yeah.
And I was proud that I was able to do that with trivial ease, while everyone else is scratching their head wondering what the hell I was doing. And then they realised, shit, that actually saves
job
a
security
step.
right there, huh? Yeah, man.
Oh boy,
I was thinking about it as like
fun.
a difference between that was such a tactile thing back then, right? I mean, you're actually cutting and placing and everything versus these days where it's, you know, sitting there drinking, you know, trying to stay awake, click,
mouse, click, and you get an RSI from your mouse.
Click.
Yeah.
What's RSI?
Repetitive strain injury.
Oh, okay, yeah.
Yeah.
But yeah, I didn't know you had done tape, man. You old. You were old.
I'm old, man. Yep, I've done tape.
That's great. Do you have any old tape designs you can show off? Oh, that'd be cool.
Probably not. Not the original, because they didn't last.
Yeah, they were
a huge amount of time. That's why you had to convert them into a proper negative image. So, you know, it's the photo emulsion stuff, which lasts a lot
like
longer.
An actual like a film processing kind of thing.
Yes,
right?
like a film process. That's why you do
which
the
some
film
of our
step
listeners,
and go to that.
all those 18% students or whatever out there have no idea what you're talking about.
No.
Film?
If I was just doing a one-off board, I would try and skip that step and lay out my thing. You know,
someday hipsters are going to be like, oh, yeah, you know, I laid this out with tape. It was totally artsy.
Totally radical, man. I was on the weed and had my lava lamp and beanbag. Oh, yeah. Speaking of which, I'm hopefully getting my beanbags soon for my lab. Custom electronics fabric.
Really?
It's going to be brilliant.
That's great.
Yeah. It's got a circuit fabric on it.
I saw the fabric.
Have to show photos.
I saw the fabric. That's right.
Yep.
Okay, yeah, we should put that in there.
I ordered that from a site that actually does custom fabric, like the T-shirt thing.
Really?
You can upload your own image, or you can buy someone else's image, and you can order all these different types of fabric with its custom print on it.
Nice.
And I think it's spoon flower.
You know, I'd heard about that because there's a lot more like programmable looms out there, rather.
Yep.
And
this isn't a loom thing. It's actually like they just get the regular cloth and they actually do a print on top. It's it's like a dye print kind of thing. So yeah. But you can choose like 5 different types of fabric, what size you want.
If people out there ever able to visit Dave's office, he's going to be like, no, don't sit on that. You'll wipe it off.
Yeah, right,
the circuits will wipe off.
Exactly. And it's cool. And it's a circuit that actually has it's a totally useless circuit. It's actually called bogus circuit is the name of the circuit, the pattern I actually got. But it's actually a symmetrical pattern that joins when you tile it together. Huh. So because it's a small image and then you tile it together, on all sides to make a bigger print, but it's seamless.
That's awesome.
So the guy's laid it out. I don't know who did it, but his name's there. But yeah, it's like, he laid it out so it's symmetrical. So when you tile it, it's a seamless electronic pattern. So you print it any size you want. So it's great.
So everybody out there can now buy curtains and get Dave's design on it, right?
I will add the link to the show notes of the actual fabric I bought.
Okay, so that'll be awesome.
It's not cheap if you get the heavyweight fabric.
Right,
It's very expensive, but gee, I just wanted it.
Yeah.
So cool.
Yep. Everybody watching.
So you can upload your own stuff and get it printed.
Yeah, that's
pretty cool. So if you want custom electronic curtains or something with your own circuit design on it, just upload it and buy it.
Yeah.
Brilliant.
All right, so I think we should do a chip of the week before we go because that was a pretty consistent.
We are over time. But
but I think that's worth it. I got a cool one.
Go.
So from Analog Devices, there's a part that actually it's called a black box, or it colloquially is at least called a black box power monitor. So this thing can do 12 different inputs, I think. Or 10 different inputs, rather. And basically what it does is it just, every once in a while, it bleeps out and it checks your power rails. And it'll store it in EEPROM. Do an ADC on your power rails, and then store it in EEPROM. And then if your whole product fails, you can go back and actually read which power rail failed first.
Oh, as in black box, as in like a black box flight recorder.
Like an airplane, yeah, exactly.
Like an airplane, right.
Isn't that cool?
Got it.
I thought
that is cool.
Yeah.
And it's the ADM 1166.
That's right, yeah. And
it's I2C interface, nice.
Right, and it can throw alarms too. So if you set normal alarms, like for live monitoring, if it gets below 10%, whatever, you can throw that over the I2C interface or whatever. And a lot of cool different little things in there. But I thought that was really cool idea. I'm not sure any of our listeners necessarily would need that kind of thing, but I don't know.
In a big design for a niche customer, a niche market, this sort of stuff is essential.
Yeah, that's true.
I've done this sort of stuff like as a discrete solution. Like I've had to build this capability into the product itself and not do it as a chip.
Oh, yeah?
I didn't have chips like this.
Yeah.
I've had to build in the firmware, and it has to continually monitor and write things to E² prom as the product's actually going, so that when it dies, you can fault find it.
Yeah.
I've had to build that
so like
capability
medical stuff and like high reliability military type stuff, right?
Yep.
Yeah,
it's important. And it's got 6 DACs in it.
Yeah.
You can actually output 6 voltage output DACs.
Yeah.
How much does a chip? Tell us the price, son.
Oh, only $10.
Oh, my Australian
$10
friends Australian listeners will know what that means. Is that one off or?
That's one off. Yeah, $10. $10 one off.
That's not too bad considering it's got 6 bloody DACs in it and a 12-bit SAR ADC and all sorts of
you got to do 48-pin TQFP, but if you can handle that, you're in good shape. Yeah. And even on here it says evaluation board $300. Right. Unless you're buying a lot of them, folks.
Unless you're buying a lot of them, we'll give you one for free.
Exactly.
We'll even toss in a coffee mug.
That's right. Oh, yeah. I gotta love the swag. Yep.
Yeah. I've gotten so many coffee mugs and bottles of grog over the years.
I know, and you can't use either of them, right? You don't drink coffee,
grog,
you don't drink beer.
Grog, is that a term in the US?
No, I had first heard that from you, so I know what you're talking about.
Oh, okay, there you go. So you know what I'm talking about. Yeah, grog, alcohol.
Yep.
Right. That's a cool chip.
Yeah, I like it.
Oh, I'll have to talk about my chip of the week next week.
All right,
you might see it on a video before then.
Okay.
Anyway,
right.
so
That'll be good.
Of a spoiler there, but once again, it's I2C as well.
Yeah.
And handy.
And chip of the week. I mean, we keep hearing from people, and I thought about it too. Chip of the week, it's fun. You want to hear. It's hard to hear about new parts, so we're gonna try and really make sure.
Is this part new?
I think it's newish.
Right.
I heard about it from a vendor, so.
Well, it doesn't have to be new. It's just got to be something,
good,
one
right?
of those obscure parts that, I didn't know that existed.
Exactly, yeah. That's what I always look for, like the kind of the weirdo parts, and LT's good for a lot of that stuff, and ADI's good. I mean, so a lot of application-specific
But they're
stuff.
usually expensive. That's because they're not high-volume products. They're, you know, niche. Yeah.
Right.
And so you do pay the penalty, but, gee, I can see this. This is pretty cool.
Yeah. All right, anything else for this week, Dave?
No, we're way over time.
Okay. One last thing.
I shouldn't say.
One last thing.
Okay.
Dilbert. I had to mention this.
Okay. There's always time for Dilbert.
There's always time for Dilbert. So Scott Adams on the site, he allows you to change he got so pissed off at his readers who kept suggesting punchlines to jokes. He said, "Fine, screw it," and you can now type in a joke ending to any Dilbert strip. And
any even all the old ones.
I think so. Yeah, and it uses his font and everything.
Oh, so it's only the last frame, the last panel.
Yeah, it's only the last.
Right, so you can't change the previous panels because otherwise it'd be stupid.
Right, that was just ripe for copyright stuff. But this is actually, and like he highlights it so that it's actually not the original. And but it's still brilliant. I love it. I love it.
Yep, that's great.
So check it out, Dilbert.
How does he produce all there? I said it before, my inbox is always like I end up getting 3 or 4 queued in there because he produces them so often. I know he produces one every day, but seems like more than that.
Yeah, I don't know, man. Something to shoot for with the blog. You got to get one a day.
Yeah, one a day, yeah. Right.
365 days of Dave. All right. Well, we should probably call it a week, huh?
Yep. And hopefully there was enough content in today's thing that people liked. Unfortunately, we did get MakerBot, we did get politics, we did get all that
bingo
shit, so sorry. Yep.
Anyways, you can catch us just like every other week. You can catch us on G+, you can catch us on Twitter, and you can catch us on email if you need to, theamphour@gmail.com. Talk to you next week.
Bye.
See ya.
Hang on.
Okay.
I'm slated to be in Melbourne next week.
All right.
Just saying. I'm not sure what's happening next week. I may or may not be here.
Okay.
So, I just thought we'd add that in. I'm still recording.
All right, so
maybe this can make it, but I don't know.
Okay.
Sorry. I haven't heard from him, though. So, anyway. That was the date, the 19th. I was supposed to be in Melbourne on the 19th. So, go figure.
Longest episode ever.
If you're listening to an hour, you're not going to care that it goes 10 minutes over. You're not going to time's up. I'm going to stop listening now, these bastards. You know? Always going over. I'm sick of this shit. I'm going to write a complaint email.